Let's take some notes. So, we're going to be using inverses of matrices to solve, which means we have to figure out what the inverse of a matrix is. The multiplicative identity is 1, just in regular old math, meaning 1 times anything's itself, no matter which way you do it. When we want to take that idea and talk about an identity matrix, it's a matrix that we can multiply by, where it doesn't matter whether it's a left multiplication or a right multiplication, we still get the same matrix returned to us. The identity matrix turns out to be a diagonal set of 1s with 0s everywhere else. Doesn't matter if it's a 2 by 2 or 3 by 3. Diagonal 1s and 0s everywhere else gets you the identity matrix. And it turns out if you multiply these matrices by 2 by 2s or 3 by 3s, we actually have that they return the same thing. An inverse, then, is when you take and you have a matrix and you can multiply it by another matrix to get the identity matrix. And so that's what we're going to be looking for. Just like the multiplicative inverses means if we have 2 and we need to multiply something to get to 1, we multiply by 1/2. We need to find something that does the same type of thing for matrices. So, to find an inverse of a 2 by 2, you simply make a fraction of 1 over the determinant, AD minus BC, and then you multiply that by the matrix D negative B, the opposite of C, A. Your determinant can't be 0 because you're dividing by it, and we don't know what the dividing by 0 is. So let's try it real quick. To find the inverse of this matrix A, we're going to take 1 over the determinant AD minus BC times D, there we go, the opposite of B, the opposite of C, A. So our A inverse is 1 over 11 times 2, 1, negative 5, 1, 3, which is 2 elevenths, negative 5 elevenths, 1 11th, and 3 elevenths. So take the time right now, real quick, by yourself, multiply A times A inverse. Across and down, please. So not too bad to convince yourself that those really do multiply together to give you the identity. So A inverse really is this 2 over 11, negative 5 over 11, 1 over 11, 3 over 11 matrix. Woo! Let's use that to solve. So first, we take our equation and we make the coefficient matrix like always. Here's our C, the x, y, the variable matrix, and then the answer matrix at the end. We are now going to multiply in front by our identity. This matrix is the same matrix we had up here. We already know the identity, or the inverse. The inverse is this. So here we have C inverse for our C. When we multiply C inverse and C together, we get the identity matrix. The identity matrix times x, y equals, what do we get when we multiply across this one and down this one? 2 elevenths times 22 is 44 elevenths plus 0, so 4. Moving to across and down, 1 11th times 22 is 22 elevenths plus 0 is 2. The identity matrix times anything is itself, as long as it's a 2-er. And that leaves us with x is 4 and y is 2. Or our solution point, our ordered point for 2. So you might want to convince yourself when multiplying that 1, 0, 0, 1 here times xy is actually xy. Don't take my word for it. Go ahead and do that multiplication out. And then meet me on the next page when you're ready. Oh, there is not another page. That's it. Yay! All right. Our matrix in our calculator. So let's put in C for the first matrix, matrix A in our calculator. So edit your matrix A to be a 2 by 2 with 3, 5, -1, and 2 as the elements. Once that's in, quit. And just on your regular screen, go to the matrix and select A. So second matrix, A, which is our 2 by 2, and hit enter. It should actually bring up on your screen what it is. 3, -1, 5, 2. So now hit second enter. So it repeats back the last thing you typed, which was the matrix A, and we want the inverse. So we can just go on the A that pops up, we want the inverse. It's going to come up with a horrible bunch of decimals. Woo, look at all those fun decimals. 0.18 repeating, -0.45 repeating, 0.09 repeating, and 0.27 repeating. So we have our inverse. If we go back in the matrix and we edit B, the second matrix, we want to make it a 2 by 1 for our answer column, the 22, 0. So make it a 2 by 1 and then put in 22, 0 for the elements. So our matrix B is 22, 0. And then quit again, back to the main screen. We want to go back into matrix, bring up our A, take its inverse, and multiply it by B, our answers. And what do we get? Let's see. Multiply by B. And I get a nice little thing coming right out of my calculator that says 4, 2. Very, very cool way to do inverses on your calculator. At the very least, a great way to check our work if we're on a calculator section. Understanding that we want to write down what our matrices are. What's our matrix A? This would be how we would show our work while doing our calculator portion at the same time. Here's our A inverse. We write down what our calculator tells us A inverse is. Here's our B, and then we can go to our A inverse B, get our answer, and report back X is 4 and Y is 2, or our ordered solution pair for 2. A little bit of fun calculator work there for you. Hope that makes sense. See you guys soon!